Hello, this is Professor Chivan Acharya again. In this video, I'll do the homework from section 5.2, and these are the homework problem from my lab math. And this 5.2 about the addition rule and the complement. Okay. First question is we were talking about mutually exclusive event. Also, there is another name for mutually exclusive we call disjoint. Question number 1. Suppose a person is selected at random from a large population. Label the pair of the events are mutually exclusive or not. The selected person has blonde hair. That's the first event. Other event is the selected person has a black hair. Okay, and these two events are mutually exclusive, of course, because if one event occurs, the other event cannot occur. In another word, two events cannot occur at the same times. In other words, if you select one person randomly, that cannot be blonde hair and black hair at the same time, the same person. Okay, therefore these two events are mutually exclusive or disjoint. They put the answer A here. Part B. Suppose a person is selected random from the large population. Label the pair of the events are mutually exclusive or not. Okay, the first event is the selected person has no children. The selected person is married. Okay, notice that these two events are not mutually exclusive because these two events can occur at the same time. Because if even the person is married, that person might have a children. Okay, therefore you might get a person that is married but has no children at the same time. In other words, same person can be married and has no children. The answer for this question is C. The two events are not mutually exclusive because if one event occurs, the other events also can occur. Number 3. According to the Center for Disease Control, the probability that the randomly selected person has a hearing problem is 0.142. The person has a hearing problem, 0.142. And the probability that randomly selected person has a vision problem is 0.094. Notice that you select the person randomly. Can you compute the probability randomly selecting a person who has a hearing problem or vision problem by adding this probability? Why or why not? Notice that it's talking about the formula. We talk about the formula here in the bottom. The question tells you, can you just add this probability to find the person who has a hearing problem or vision problem? Okay, in other words, can you find probability of a hearing problem? Just put the H, or a vision problem, just put the V. Can you find the probability just adding probability of hearing problem plus probability of vision problem? Can you just do that? Can you do this? In other words, can you add just to these two probability to compute the probability of H or V? No, we cannot, because this formula we talk about next question only used if these two events are mutually exclusive. But this is not mutually exclusive because you can find one person that might have hearing problem and vision problem at the same time. In other words, it is possible that one person could have both vision and hearing problem. Where you cannot use this formula, because this formula only for two events if they are mutually exclusive. Therefore the answer is D, because hearing and vision problems are not mutually exclusive. So some people have both hearing and vision problems. Okay, therefore you cannot use it. Question number 4. If E and F are disjoint even, again the disjoint is same as mutually exclusive, I mentioned before. If E and F are disjoint, then probability of E or F equals to probability of E plus probability of F. That's it. Because they are disjoint, and probability of E or F gonna be probability of E plus probability of F. Notice that our topics is addition rule, and here plus addition comes in the formula. If they are mutually exclusive or disjoint, you can just add individual probability to find the probability of E or F. Okay, but if they are not disjoint, okay, and the formula for probability of E or F gonna be different. And notice that they are not disjoint. For question number 5, the probability of E or F here is gonna be probability of E plus probability of F minus probability of E and F. Notice that we use AND here. Probability of E and F, you subtract that from the probability of E plus probability of F if they are not disjoint event. Therefore the formula for disjoint event and not disjoint event are different. Okay, the probability, question number 6, also about the probability. And here's a experiment where the sample space is 1 through 12, and there's two events, F and G. F is 5, 6, 7, 8, 9 outcome. G has 9, 10, 11, 12 outcome. Okay, assume that each outcome is equally likely. List outcome of F or G. Listen, list outcome of F or G. First you do that and find F, probability of F or G. Listen, that's the different things here. First find the outcomes in F or G, and second question, find probability of F or G by counting the number of outcome F or G. Okay, now you do the same thing, find the probability using general addition rules we just mentioned here in the next part. Well, let's find outcomes in F or G. F or G means you got to find the all in F and G all together. In other words, put F and G together to find F, A or G. The answer, pick this one. Notice that you pick only B if there is nothing in F or G, but there is something in F and G all together. Therefore F or G going to be, let's find all outcome together, 5, 6, 7, 8, 9, 10, 11, 12. Notice that 5, 6, 7, 8, 9, 10, 11, 12. All these elements are in F or G. How many there? 1, 2. Let's count it. 1, 2, 3, 4, 5, 6, 7, 8. 8 outcome, right? 8 outcome. And the sample space, how many outcome here? 1, 2, 10, 12 outcome. In the sample space, you have 12 outcome. 12 outcome in the sample space. Now this the part A is listing all the outcome in F or G. For part B, find F or G by counting number of outcome in F or G by counting. For how many outcome in F or G? 8. How many outcome in sample space? 12. 8 over 12. And you divide 8 by 12, you get decimal and round to decimal, 3 decimal places as needed. And the answer must be 0.667. 667. If you divide 8 by 12, you get 0.667. Notice that we found the probability of F or G by using counting. But in the next question, you determine the probability using general addition rule. To find the probability using addition rule, you have to first identify, are those outcome F and G are disjoint or mutually exclusive. Notice that they are not mutually exclusive because the outcome here 9 is the common. Okay, in other words, F and G, F and G both has 9 in common. Therefore, these two events can occur at the same time. They are not mutually exclusive. Okay, F. Therefore, you use this formula, question number 5 formula, probability of F or G equals to probability of F plus probability of G minus probability of F and G, because notice that they are not disjoint or exclusive. You pick part A, not part B. Notice that part B doesn't have a negative in the formula, therefore we choose A. Now you can put the number here in the box, number in the box, number in the box, and you do the math and find the number in this box. Okay, let's find the probability of F. Again, you notice that you find probability of F or G, right? See, that's what you're looking for. F or G. You see that? F or G, F or G. What's the probability of F? How many on F? 1, 2, 3, 4, 5. Therefore, 5 out of 12. That's probability of F. Plus, what's the probability of G? How many G? 1, 2, 3, 4. 4 out of 12. Minus how many outcome in probability of, how many outcome in F and G? Only one. 1 out of 12. Therefore, in this box, you divide 5 by 12, put it here, and round it to 3 decimal places, which is going to be 0.417. And this box, you type 4 divided by 12, which is going to be 0.333. And in this box, you type 1 divided by 12. Divide and you type 1 divided by 12, which is going to be 0.083. And if you add these two numbers, you add it and subtract this number, you get 0.667, which is same as we found before by another method. Probability of F or G going to be the same. In question number 7, similar to question number 6, but here these two events E and G are mutually exclusive, because if you look at E and G, there is no outcome in common. 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18. Therefore, these two events are mutually exclusive. You choose B as answer here, because in A and G, there is nothing. Okay, in other words, there is no common outcome between E and G. And the question is, are E and G mutually exclusive? The answer is yes, because E and G has no outcome in common. That put the answer C. All right. Now question number 8. There is another type of the problem which involves complement. Remember that we talked about the complement before? I mentioned the complement. I not talk about complement. The complement of the event is the outcome not in that event. Notice that E is 6, 7, 8, 9, 10, 11, 12, 13. Okay, E complement has all the outcome in sample space S, not in E. Therefore, E complement should have 3, 4, 5, and 14. Notice that 3 is not in E, 4 is not in E, 5, 14 are not in E. That's the E complement. And the first question is find E complement. The answer for A gonna be this, the E complement. You type 3, 4, 5, 14 here. Now, second question is find probability of E complement. Notice that this is find E complement, this is the find probability of E complement. Look at the P in the front. Therefore, the probability of E complement is going to be how on E complement. How many on E complement? 1, 2, 3, 4. 4 divided by how many on the sample space? 1, 2, 3, 4. If you count, there's 12. 4 over 12, which is going to be 1/3. But in the homework, you type integer or decimal, rounded to 3 decimal places as needed. If you divide 1 by 3, you get 0.333. That's the answer. Okay. Question number 9. Find the probability of the indicated event if probability of E equals 0.20, probability of F equals to 0.55. Find probability of E or F. Find probability of E or F. If probability of E and F is 0.15, pretty much using this formula, probability of E or F equals probability of E plus probability of F minus probability of E and F. Okay, now let's substitute the value of probability of E, which is here of 0.20, plus let's find the probability of F, which is 0.55, minus probability of E and F, which is 0.15. Now if you add these two numbers and subtract 0.15, you get 0.60. That's the probability of E or F. Number 10 is similar, but only for mutually exclusive. You can use the formula from the top. Remember that you have to use this formula for mutually exclusive. Okay. Now number 11, the find probability of P E complement if P equals 0.38. Alright, looking for this probability of E complement, and the formula for that is going to be 1 minus probability of E. Okay, that's the formula for probability of E complement. 1 minus probability of E. You have 1 minus probability of E going to be 0.38. You subtract 0.38 from 1, you get 0.62, and the probability of E complement going to be 0.62. Question number 12. 12 is slightly different. You got to find the probability of F. Listen, find the probability of F. Okay, but the given here is probability of E, probability of E or F, probability of E and F. Therefore, we are using the same formula we had it before, this formula here. Let's write the formula first. The probability of E or F equals probability of E plus probability of F minus probability of E and F. And now we have to put the value of each probability of this E or F. Here going to be 0.05. Okay, I'm sorry, E or F going to be 0.85. 0.85 plus equals to the probability of E we have here is 0.60. 0.60 plus probability of F we don't know, that's what we are looking for, minus probability of E and F, which is 0.05. Okay, now let's do the math here. You pretty much add this, subtract this and this two. What you get is 0.85 equals 0.55 plus probability of F. Notice that 0.60 minus 0.05 is 0.55. Now to solve for probability of F, which is unknown, you subtract 0.55 both sides, 0.5 both sides, and this cancel, and 0.85 minus 0.55 going to be 0.30 equals probability of F. Therefore, in this question, probability of F going to be 0.30. Question number 13. Use the data in the following table, which lists the survey results from the high school driver at least 16 years of age. Okay, and here the thing, there's a row for texted while driving, no texting while driving, and drove when drinking alcohol, yes. Drove while drinking alcohol, no. And to find the probability, you got to find out how many people on the survey. Let's find how many texted while driving. Add this row, 709 plus 3183. Let's find the total people who text while driving is 3892. If you add 141 plus 4676, which are the people who do not text while driving, this is going to be 4817. Okay, and notice that 3892 are the people when text while driving. 4817 people are the people who do not text while driving. And if you add the column, S means who drove when drinking alcohol. Let's see how many people drove while drinking alcohol. You add 709 plus 141, you get 850. You add 3183 and 4676, you get 7859. And 7859 are the people who do not drive when drinking alcohol. And how many people on the survey? If you add these two numbers, you get 8709. Or if you add these two numbers, you get same number. Therefore, in the total number of people in the survey is 8709. Okay, that's the total number of people in the survey. That's what we need. We need to find the probability. And the question is, if one high school student is randomly selected, find the probability that the selected driver texted while driving and drove when drinking alcohol. He does both at the same time. Okay, find the probability that randomly selected students who does text while driving and drove drinking alcohol. And how many people does both at the same time? Notice that 709. Listen, 709, 709 people text while driving, also drove while drinking alcohol. For the priority going to be 709 does both. Both here is text while driving and drove when drinking alcohol. Out of 8,709. And if you divide these two numbers and round it to 3 decimal places, your answer is going to be 0.081. 0.081. Question number 14. A golf ball is selected from a golf bag. If the golf ball contains 10 yellow balls and 6 black balls and 6 brown balls, find the probability of the following event. The golf ball is yellow or black. Notice that here's a probability to find yellow or black. Technically, you are looking for probability of yellow or black. Let me write Y for yellow, B for black, and or in the middle. And we are using the formula. We had it before. But are they mutually exclusive? Yes, they are. Because you cannot get one ball which is yellow and black at the same time. In other words, these two events cannot occur at the same time. And if not, the formula is going to be probability of yellow plus probability of black. Okay? And what's the probability of yellow? How many yellow here? 10. Out of how many ball? Remember that 10 plus 6, 16. 16 plus 6, 22. 22 plus how many black? 6 divided by 22. In other words, 6 plus 16 divided by 22, which is going to be 0.727 when you round it to 3 decimal places. Okay, that's the answer, 0.727. Alright, question number 15. A golf ball is selected from a golf bag. Similar question. How many ball there? 7, 8, 9. 7 plus 8 plus 9. How many ball? 24 ball. 24 ball. And total balls is 24 ball. And the question is asking for what's the probability that the golf ball is not type A? Probability of not type A equals to 1 minus probability of type A. In other words, this is the complement of A. This is A. And we had the formula before, probability of complement of the event equals to 1 minus probability of the event. And 1 minus what's the probability of type A? How many type A here? 7 type A. 7 divided by 24 out of 24. If we subtract 1 minus 7 divided by 24, round it to 3 decimal places, your answer is going to be 0.708. That's the answer. And question number 16. The following table shows the distribution of the murder by the type of weapon for a murder case in the particular country over the past 12 years. In other words, here's a weapon and there's a probability. In other words, what percentage of murder is done by handgun? What percentage of murder are done by rifle? That's the question. That's the table says that. Okay, and this is the outcome. This is the probability. And the first question is that the given probability model? Why or why not? Yes, it is, because the sum is 1. Okay, sum of the probability is 1, and each probability are between 0 and 1. In other words, it is the model because rule required for the probability model are both met. Okay, number 16 part B. what is the probability that randomly selected murder has resulted from the rifle or shotgun? Okay, rifle, listen here, rifle or shotgun. There is two event here. Probability of a rifle, I write R for rifle or S for shotgun. And notice that these two events are mutually exclusive because you cannot find the person who is murdered by both in particular. Therefore, to find the probability of rifle or shotgun, you add the probability of rifle and probability of shotgun because they are mutually exclusive. What's the probability of rifle? 0.022, 0.022 plus what's the probability of shotgun? 0.033. The answer is going to be 0.055. Here 0.055. Notice that we're using OR here, okay? That's the crucial point. Alright, interpret the probability. And we remove this one because it's a exactly. Therefore, we use the A. And if 1000 murderer were randomly selected, we would expect about how many? You multiply 0.055 by 1000, which gives you 55. Therefore, if 1000 murderer were randomly selected, we would expect about 55 of them to have resulted from rifle or shotgun. That's the answer. Part C. What's the probability that randomly selected murderer resulted from handgun, rifle, or shotgun? In other words, you have to add the probability of handgun, a rifle, or shotgun, all three probability. Your answer must be 0.531. Okay, you add probability of handgun and you add probability of rifle or probability of shotgun, and 0.531 is total. And how to interpret this similar to before? You don't use this one because say exactly. Use the bottom one because say would expect. How many would expect out of 1000? You multiply 0.531 times 1000, right? This gives you 531. Therefore, we expect about 531 murderer have resulted from handgun, rifle, and shotgun. Okay, next question, part D. What is the probability that randomly selected murderer resulted from a weapon other than gun? Okay, here's the thing. Other than gun, weapon here is knives, hands, and fist, and others. And if you add these three numbers, 0.134, 0.056, and 0.133, you get 0.323. Okay, therefore the probability that the randomly selected murderer resulted from weapon other than gun is 0.323. Why? Because you add these three probability, which are probability of murderer other than gun. And to interpret this probability, you multiply 0.323 times 1000 because we select 1000 murderer. Okay, this gives you 323. And if 1000 murderer were randomly selected, we would expect about 323 of them have resulted from weapon other than gun. That's the answer. Again, don't choose B. We say exactly. Exactly is not interpretation for the probability. Question 17 is similar to we did previous questions. Therefore, I'm not going to do question 17.
Question number 18. Harris Interactive conducted a survey in which they asked adult Americans 18 years or older whether they use social media regularly. The following table is a subsample based on the results of the survey. Complete part A through D. So here's the table here. And if you look at the table, there's age range and 18 to 34, 35 to 44, and so on. And if you look at the second row, you say social media user, and then other row does not use social media. So you have a total here, and if you look at the total here, 320 is total people who use social media, and 170 is total people who never use social media. And if you look at this column here, 142 represent the person who in this age group 18 to 34, 122 people are in between this age group 35 to 44, and so on. So technically there are 498 people on the survey. So that many people are asked about the user of social media, and so we get this many response. So the question is, first question is, if an adult American is randomly selected, what is the probability they use the social media? So if you look at the question part A, P as a probability use social media. So to find the A, let's see how many people use social media. And if you look at the social media, the user 320 divided by total number of people is 498. Okay, so if you divide it, and the instructions say round to the 2 decimal places as needed, and use your calculator to divide and round your answer to 3 decimal places, is going to give you 0.643. Part B. Similar question, if an adult American is randomly selected, what's the probability they are 45 to 54 years of age? So looking for probability between 45 and 54. So how many people are between 45 and 54? Look at the table here. That's the column we're going to use, and 125 is number of people in that age group 45 to 54. So I'm going to put 128 out of how many people on the survey? 498. Remember that total number of people on the survey always in the denominator to find the probability. So if you divide this and round it to 3 decimal places, you get 0.257. For C, you do this similar. So for the C, looking for if an adult American is randomly selected, what's the probability they are 35 to 44 years old social media user? That means you got to find the how many people are 35 to 44 years old and also they use the social media. Remember that it's the end here. So how many people use social media and also in that age group? So if you look at the table here, use the social media and the age group like 88. See, the 88 is the number of people who all use the social media and also between 35 to 44. So for the C, how many people? 88 divided by 498 again, and down it to 3 decimal, gonna be 0.177. Okay, for part D, you have to be careful. For part D, you're looking for probability between 35 to 44 or use the social media. Notice here, 35 to 44 or use the social media. So you have or in the middle. And I'm going to write the formula, probability of A or B equals probability of A plus probability of B minus probability of A and B. So if I use this formula, A here is 35 to 44, B here is use social media, and use this formula since they are not disjoint because there is a people who are between 35 to 44 and also use the social media, which are 88 number of the people. So I'm looking for probability of 35 to 54, sorry 44, or social media user. Okay, let me write social by itself. I'm not gonna write social, use social media. I just write social. That's the B, like here. So what's the formula? Probability of 35 to 44 plus probability of social media user minus probability of 35 to 44 and social media user. Okay, social media. So basically we use this formula to find this part D. So I know what's the probability of social media user. I have it in the part A, so I'm going to use this number 0.4643 because I have it here. Probability of use social media is going to be 0.643. What's the probability of 35 to 44 and social media user? We found it here in part C. I'm going to use that probability, which is from part C, 0.177, but I don't have this probability here. Okay, remember that part B is different, 45 to 54, but I'm looking for probability of 35 to 44. So let's find this separately here. What's the probability of 35 to 44? Let's find that. To find it, you find how many people are between this age 35 to 44. You have 122 divided by 498, and you divide, you get this can be 0.245. So I'm going to use that here. 0.245 is the probability of 35 to 44 plus probability of social going to be 0.643 we found in part A, and minus probability of 34, 35, 44 and social going to be 0.177 from here. Now if you add this two and if you subtract this two, here's probability going to be let me do that here, 0.711. okay, that's the answer for part D. Question number 19. The table lists the drinking habit of group of college students. If a student is chosen at random, find the probability of getting someone who is a main or a non-drinker. Okay, again the question here. You got to find the main or non-drinker. Okay, main or non-drinker. That's for here in the question you're looking for probability of main or non-drinker. So if you have or here, this is the general addition rules, and you got to use this formula we had just before. See, probability of A or B equals probability of A plus probability of B minus probability of A and B. So to find the or, you got to use this formula. So here, if you wanna find probability of main or non-drinker, what is the formula going to be? The formula going to be probability of main plus probability of non-drinker minus probability of main and non-drinker. Okay, non-drinker. So let's find the probability of main. Okay, again I know how many men here. So total is given. You guys see this column is total 175 men. How many women? 222 women. How many non-drinker? 322 non-drinker. How many regular drinker? 56. How many heavy drinker? 19. You have a total here. Both row and column as a total. So how many people on the survey is 397? So basically 397 goes in the denominator. 397, of course 397 here minus 397 here, because I have a 3 probability. Each probability, when you find them, you got to put number of trial in the denominator, which is 397. Okay, so how many men here? Look at the men, 175. How many non-drinker here? Non-drinker, 322. How many men and non-drinker? Watch here. Men, non-drinker. 135 people are men, also non-drinker. It's 135. So now 397 common denominator, and if you add 175 with 322 and subtract 135, you get 362 divided by 397. Of course, when you divide that, you get 0.912. That's the probability of the main or non-drinker, which is going to be D. Okay, last question 20. Last question 20 is similar to the other questions, except you have no total is given here. Unlike the previous question, this question doesn't have a total. So here there is a accident occur. That's the question. Number of driver involved in the fatal car accident in 2020 in various condition. So it looks like you have weather condition as a column, light condition as a row. I should say this is light condition here, and normal weather, this many light daylight, that many fatal accident, and in the normal weather, in the dark light condition, that many fatal accident. So looks like 15 car accident occurs in snow condition in the dawn. So the question here is doesn't have a total. In other words, how many accident happens in normal weather? So to find that how many accident occurs in normal weather, you got to add all this number to find the total number that or total number of accident that happens in normal weather. So you got to add this all 1 2 3 4 numbers of the row. You get this number equals to 23,853. that many accidents, fatal accidents in the normal weather, and how many fatal accidents on the rain weather. We have to add all this rain with 2688. You got to add that, and how many accident on the snow weather. You add them total again, you get 300 accident. So this is the total number of accident in different type of weather. So next column, you see daylight column. Then how many accident occur in daylight? You add the first this column, daylight column, to find 12,205. That many accident on the daylight weather. How many accident on the dark but lighted weather? There are, if you add all these three numbers, you get 6140. And how many accident on the dark weather? The 7308. You add this dark column, and dark's down column, you add all them together, you get 1188. So we found each column total and each row total. Okay, so if you add this column, these three numbers in the column, whatever you get, that's the total number of accident in 2020. So if you add all them together, you get 26,841. Even if you add this way, you get same numbers. So it doesn't matter which way you add it. This is the total number of accident. That goes to the denominator. Remember that when you find the probability, that must be goes to the denominator. Now let's find the probability of each part here. Determine the probability that randomly selected fatal crash occur in normal weather. So you can find the probability that occur in normal weather. Technically, in this question, you're looking for probability of normal weather. So this is probably looks like this: probability of normal weather. That's what I'm looking for. So how many normal? That's the part A. Look at the normal accident here is 23,853, right? 23,853 divided by total number of accident in 2020 is 26,841. 26,841. If you divide and round it to your answer to 3 decimal places, you get 0.889. Okay, for part B, find the probability that randomly selected fatal crash occur in daylight. So pretty much looking for probability of daylight. Okay. So again, total accident going to be 26,841 goes to the denominator. And how many accidents happen on the daylight? You got to find the daylight here. Number of accidents on the daylight is 12,205. So I'm going to put 12,205 and round it to the 3 decimal after division. You get 0.455. Okay, part C. Let's see what's part C. Determine the probability that a randomly selected fatal crash occur in normal weather and in daylight. Look at the end here. Normal weather and in daylight. So okay, normal weather and in daylight. So you're looking for probability of normal and daylight. That's what I'm looking for. Okay. Again, denominator is total number of accidents on that year, 2020, 26,841. And how many accidents are in normal weather but the daylight condition? Let's see. Normal weather and daylight condition is this. Watch here. Normal weather, daylight condition. 11,076 accidents are in daylight and also normal weather. So I'm going to put 11,076. If we divide and round it to 3 decimal, is going to be 0.413. Okay, part C. Sorry, part D. Determine the probability that randomly selected fatal crash occur normal weather or in daylight. Look at the difference between C and D. Here or here. Okay, or daylight. So again, we had the same formula like we used in previous question. Normal or daylight. Okay, and by the rules you have to add the normal probability with the daylight probability and subtract normal and daylight probability. So this is going to be 0.889 plus 0.455 minus 0.413. Okay, because of or you add individual probability and subtract both probability, which is and probability, and if you add and subtract, you'll get 0.931. Okay, part D. Part A, the last one. Would it be unusual for the fatal crash in 2020 occur in the dark outside and raining? So dark outside and raining. So probability of dark and raining. That's what I'm looking for. Notice that and here. So how many fatal crash occurs in dark outside and also raining is 791. So 791 fatal crash occur in the rain and also in the dark. So I'm going to put this in the numerator. There are a total number of accidents again, like before. You have it here, or you have it here, 26,841. If you divide, you'll get 0.029. So this probability is what? Less than 5%, which is 0.05. So this is unusual. So the question is, would it be unusual? That's the question. Would it be unusual? Look at the question here. The answer is yes, it is. So you got to say that the probability that randomly selected fatal crash occur when it is dark outside without light is raining is unusual. How about the probability? How much is 0.029, and this value is less than 0.05, so it would be unusual. Okay, this might be misleading because people are driving when it is dark and raining, because less people are. Notice that it's definitely going to be unusual, looks like, because of the probability, but this is misleading in the sense that people are driving less, obviously you expect the probability is very less. So sometimes it looks like misleading. Okay, so you got to put this might be misleading because less people are driving when it is dark and rainy. Okay, well, that's all. Thanks so much for watching the video. Shaban again.